Alright, so now that I had time to think a little bit more about what I'm going to say, this will be a little bit better video. But in the first video, we explained what exercise physiology was, kind of went over glycolysis and the breakdown of a molecule, glucose, something that we get from our food that we eat. So this is like this is like energy in its raw form. It's not really energy, we can't use it. We have to first convert it to something that we can use, but it starts as glucose, it has to start somewhere. And then it goes through this cycle called glycolysis, and then that glucose turns into something called pyruvate. And then the pyruvate then can finally go through two cycles, or it has two paths to go, either a slow path to get a lot of ATP down the road, which is aerobic, it's a slow path, or go to the fast path and form lactic acid and give you energy right away, which is called anaerobic. So remember how the body is a machine essentially, and you can't do anything without energy, without ATP or energy. Just like in the world, the metaphor I used was in the world that. So we're just putting aside that ATP. Think of as money. To relate it to the real world, because you learn much better when you can relate things to your real life. You can't do shit in the world usually without money, so you can't do anything in your body without ATP. A body that does not have ATP is useless, just like a person. Gotta be careful about saying that, but a person that has absolutely no money, I'm gonna say is useless, but they can't really do a lot of things with no money. So it's the same thing kind of. So glucose is like motivation, or for a lame metaphor, say glucose is like motivation or potential, like let's say glucose is like an opportunity in the real life, whatever. An opportunity doesn't really mean anything unless you use it and make money from it. Same thing as glucose. Glucose by itself is useless until you actually use it. So glucose has to first go through glycolysis, which is a process of like using the opportunity. We'll say it's action. Glycolysis is action, but glycolysis is a process to form that glucose into energy. Final process is ATP, but first it stops as pyruvate. Pyruvates. Okay, so glucose. The body converts glucose to pyruvate through the process of glycolysis. This happens in the cell's cytosol. Cell's cytosol. Now remember that, hopefully you remember that the body has cells in the body. You have like millions and trillions upon billions of cells. And after you eat, glucose floods your system because you eat this food molecule, food substance, whatever you want to call it, and your body converts it to its simplest forms, which are glucose, proteins, and fats. But we'll focus on just glucose here. So it converts it to glucose, and your body, this glucose floods your cells your body floods your cells with glucose. Now, glucose has to get inside the cell in order to form glycolysis, or to go through glycolysis in order to form pyruvate and ATP. So we got the glucose into the cell. This is the point of insulin, which we'll talk about later. Actually, I don't think we talk about in this test, but insulin brings the glucose into the cell. And now once glucose is in the cell's cytosol, underline it because that's pretty important to know, that glycolysis happens in the cell's cytosol. So you have glucose, it's in the cell, and the cell cytosol, which is the outside. The cytosol is like the outside, is the liquid inside the cell, essentially. You have the cell, it's a little circle, glucose goes into it, and this is the cell cytosol, the whole outside area. And inside you have all the organelles, like the mitochondria, the nucleus, and whatnot, but the cell cytosol is what we're focusing on, what we care about. And here, glucose gets converted to pyruvate through the process of glycolysis. And then this whole process is more complicated than this, but we'll just skip it and say you get glucose and then you get pyruvate all in the cell cytosol. And now pyruvate has two options. It can either form lactic acid, like we said, or lactate, we'll say, or it can do something called the Kreb cycle. So now we'll differentiate between these two. Now, if it forms lactic acid, that is when it's considered aerobic. This whole process is considered aerobic, which we'll talk about, because aerobic or anaerobic. Because remember, anaerobic means without oxygen. This whole process doesn't have oxygen involved. So oxygen is not involved to the very last step. So glucose going to pyruvate is an anaerobic process. It's glycolysis. Glycolysis is anaerobic. But glycolysis always happens. which is why saying aerobic glycolysis means with oxygen isn't technically correct, because in order to get to the point where it needs oxygen, it has to go through glycolysis, and glycolysis is anaerobic. Glycolysis is always anaerobic. Never say glycolysis is aerobic. Now, glucose goes to pyruvate, and then pyruvate can either form lactic or Krebs cycle depending on one thing, depending on how fast you need, or really it depends on the intensity of the activity. But another word for intensity is how fast you need energy, if you think about it. Because during a very intense exercise, during sprinting, during jumping, during throwing, during, mostly sprinting, jumping, throwing, whatever, insanity, whatever. Insanity, so how fast you need the energy, whether you need it extremely fast, because your body needs the energy right away because it's doing a very high intense exercise. You just broke out into a sprint out of nowhere, so your body needs to give you energy extremely fast. So in this instance, your body will go through something called anaerobic respiration because you need energy really very fast. So your body will go through, bring the glucose into the cell, convert glucose to pyruvate. Pyruvate will then form lactic acid because you need energy right away. This gives you energy very fast, lactic acid. It gives you 2 ATP if you need to know the numbers. It's not a lot of ATP, but it's still energy. So your body gives you this energy extremely fast. So when you need energy fast, your body does this anaerobic respiration. Respiration, again, is another fancy word for just this process. It goes through anaerobic, and it gives you energy. That's anaerobic. It's when you need energy extremely fast. So it's a very fast process. So let's say, go to an instance. Now, what activities would you need? What activities do you think you would need anaerobic respiration? Now, you rely on anaerobic activities. That would be sprinting, jumping, throwing, things that you need energy right away. Gymnastics. You need energy right away in these activities, so your body will go through lactic acid or go through this process, glycolysis, forming lactic acid, and it'll give you energy right away. Now, vice versa, if you're like doing long distance running, you're biking, or you're swimming, or you're walking, you're still exercising, you still need energy, but you don't need energy right away. You don't need it extremely fast. Your body has time. Now, your body always has a reserve of ATP built up, but just like how most people have a bank account and they have money in the bank account, they have ATP on reserve. So they normally have energy saved up. But when you need more and you start exercising, your body doesn't have a high need for energy. So it doesn't have to go through this process of forming lactic acid or anaerobic or the fast glycolysis to give you energy right away. You have time. You're running, you're walking, you're cycling, you're swimming. You're doing an exercise that doesn't require energy extremely fast right away. So in this instance, your body will go through something called aerobic respiration, which is called the slow. So we'll just delete all this. So if you don't need energy right away, can't spell. If you don't need energy right away, your body will go through aerobic respiration. This is known as a slow cycle. The easy way to think about it is, does the activity need energy extremely fast, or is it is it a longer duration activity? So we'll say longer duration. Is it a longer duration activity where you don't need energy right away? If it is, it's probably aerobic. Anaerobic gives you energy extremely fast. Just think of it as the fast energy system. So it's a short and explosive. So if the activity is short and explosive and needs energy extremely fast right away, it's anaerobic. That would be sprinting, jumping, throwing, gymnastics, whatever. These require anaerobic. So these are 2 energy systems. Now there's one more energy system that we'll hit in the next video, but these are the main energy systems, anaerobic and aerobic. The reason why, because aerobic never gives you energy right away. It only gives you like 2 ATP. So it's not that effective. It's just short and powerful. So whenever you think of the word anaerobic, think of the word Yes. Think of the word powerful. Powerful system. Sprinters rely mainly on the anaerobic system, so it's more powerful. It gives you energy right away. Whereas aerobic, I'm not going to say is weaker. It's just a slower, long distance duration. This is what slow twitch muscle is. This is what like long distance runners, marathoners, cyclists, they rely on the anaerobic system because they give energy. Their activities is a long duration. They need energy over a long period of time, so they depend on aerobic. This gives you a lot more energy than the aerobic system, as you can imagine, because remember how if you want something extremely fast in life, most likely it's not going to give you a lot of it. It'll give it to you fast, and that's why this is very, very fast, but it only gives you a small amount of ATP, but it's so fast that it can last for like 3 minutes. Whereas aerobic is very, very slow, but it gives you a lot more energy, a lot more ATP in the long run. So that's an easier way to think about it. Slow, aerobic, fast, anaerobic.